So hi everyone, welcome to my YouTube channel. In this video I am going to explain you about the experiment on bar pendulum, that is determination of g using bar pendulum. Aim is to determine the value of acceleration due to gravity g using bar pendulum, that is L versus t and L square versus L t square graph we have to plot. So apparatus here required are bar pendulum, telescope, steel knife edge, support for the knife edge, and a stopwatch and meter scale. So this is the bar pendulum, okay, and here is the knife edge, so which is supported by this, and this is the stopwatch, and this is meter scale. Okay, these are the apparatus required, and this is the diagram for this experiment. Cross wire, this is a knife edge. Okay, this is the plate where we can hold this bar pendulum, and how to take the readings I will explain you. This bar pendulum has around total 19 holes, okay, and this is the point where center of gravity exists. So the middle hole, that is center of gravity. So from this point we have 9 holes above and 9 holes below, that means total 19 holes. So this is where the center of gravity exists. Then if we take the distance from this hole to all different holes, each hole is having 5 centimeter gap. Then if we measure at the last, this is 5, 10, like that. If we measure the last hole, that is around 45 centimeter away from the middle, the central hole. That means 9 readings we have to take, okay. So in this tabular column you have to write all the distances 5, 10, 15 up to 45. So first you have to start the readings taking from 45. So for that you have to measure the time for 20 oscillations. So here you can see the first reading, that is 45 centimeter first hole, that is away from the middle hole. So if we start taking reading, just move little bit, then start taking reading. I will start here stopwatch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So you can see for 45 their distance they also got 31 second. So similarly again for 20 oscillations you have to note down the time, how much it is going to take. So here they have written 32, and take the average of these two. So in this column you have to write the mean time t. Same procedure you have to repeat for 40, 35, 30 other different distances up to 5 centimeter. Okay, then note down the time for first time, second time, take the average, write down the average in this column, mean time t. Then next column you have to calculate the time period, that is capital T is equal to small t by 20 second. So you have to calculate for all the different distances. Then you have to square the time period, capital T square, then write down the values. Next what you have to do, you have to square the length. So this is the distance of the point of suspension from center of gravity. So you have to, this is nothing but capital L. You have to square this column and write down the values. Next what you have to do, you have to multiply L into T square. So here it is L into T square. Okay, first and this column. Then write the value. Next, what you have to do, you have to plot the graphs. So here we have to plot two graphs. First graph is time period versus length, capital L. Okay. Next graph. So here this is the graph of L square versus L into T square. So two graphs we have to plot. So in the first graph here, if you plot time period versus capital L length for left hand side and right hand side, because we have total 9 holes above and 9 holes below from the center of gravity. So if we plot, the curve is like this in the decreasing order, then it increases. So after that, what you have to do, you have to measure the value that is minimum. So you have to just draw a line that must be connect to the x-axis. Okay, minimum point. Take the distance from the two minimum points from left and right side, that you denote it by letters E and F. Okay, this distance you have to measure. So here if you measure from left and right side, it is about 50 centimeter. Then you can go for calculation. Okay, so here the distance after plotting the graph of time period versus length L, EF, that is around 50 centimeter. Then next is time period, how you can measure at that EF point. What will be the time period that you should note down from graph? That is for 50 centimeter from this line, this is mean time period. So 1.44 here from the graph. So the formula for the time period is given here, 2 pi into root of EF by G. We want to calculate acceleration due to gravity, so you can just modify the formula, 4 pi square EF divided by Tm square. If you substitute value of EF and time period in this formula, you will get the acceleration due to gravity about 953.81 centimeter square. You can convert it to meter per second square. Then 9.53, that means it is near to the standard value. 9.8 is the 9.8 meter per second square is the acceleration due to gravity. So this is near and this value is correct from this experiment. Then radius of gyration, how you will calculate? Capital K is equal to EF, mean distance, EF divided by 2, that will be 25 centimeter. So in the next graph also you have to calculate acceleration due to gravity by plotting L square length square versus L into T square. So here is the graph. So first you have to plot this graph, then you can calculate the slope. Slope is equal to, here they got about 25 centimeter. Okay, from the slope, this value you have to note down. Okay, then acceleration due to gravity from this second graph, we have the formula G is equal to 4 pi square into slope. Okay, if you substitute the value of slope, you will get the acceleration due to gravity. Again, it is 985.96 centimeter per second square. So if you measure in terms of meter per second, then it will be 9.8 meters per second square. Then this is also a correct value from this graph. And intercept, how you will get the intercept here? Here you have to join the line up to point P, where this straight line is going to connect with the x-axis. So that you should take it to point P. So from graph they got the value of OP, that is how much you will get, that you should note down here from the x-axis, negative x-axis value, and take the root of that. So they got about 27 centimeter after taking root. So then this radius of gyration value are also near, and acceleration due to gravity values are also near. So from this experiment we can write the result for the acceleration due to gravity from L versus T graph, time period, and radius of gyration. Okay, then and L square versus LT square graph, acceleration due to gravity and radius of gyration. And here so you can write the results from first graph L versus T, the acceleration due to gravity, how much got you can write, and the time period, radius of gyration. Then from second graph L square versus LT square, acceleration due to gravity and radius of gyration. So both these two values are near from these two graphs. So this experiment is helpful to calculate acceleration due to gravity. So I hope this video is helpful. If it is helpful, please like, share and subscribe my channel. Thank you for watching.